Hello, and welcome to another installment of Critical Thinking. I'll be your host, John Beverly, and today we're going to be discussing the square of opposition. But first, as usual, I'll have you meditate. Please go do that. Navigate to leaves on a stream in this instance. I want you to be focused as we discuss this square. So when you are finished, return, and we'll get started. Assuming you've done that, let's move over to here. We'll call the universal existential particular distinction, and of course Crayon Logic, my Instagram handle. No, recall as well this was brought up in the context of the executioner's puzzle. In this puzzle, you have 10 people in a line. They're going to be executed unless they can say what color hat they're wearing. The hats are either black or white. They cannot see their own hats, but they can see the hats of people standing in front of them in a line. So the first person can see 9 other hats, for instance. Then an executioner is going to come to each, ask them what color hat they're wearing, and if they say the right color, they get to go free. If they do not, they are, executed. The task here was to devise a strategy for figuring out how to make it so that the first person had a 50% chance of walking away without being executed, and the other 9 had a 100% chance. All we knew here was that there was going to be some arrangement of colored hats. We did not know how many black hats, how many white hats were going to be assigned. In this puzzle, when we were solving it, we did observe that there must be either an even or an odd number of black and white hats. So we didn't know the arrangement, but we did know that whatever the arrangement was, it was going to be either an even or an odd number with respect to black or white hats, right? As you can see. Now, this was a way of abstracting away from possible arrangements of hats. But now we, of course, couldn't go too far in our abstraction, or any arrangement is going to have a numerical value, right? 10. They're going to be 10 numbers or 10 hats, right? That's the sort of information we already had. It wouldn't help us find out any kind of strategy for solving the puzzle. But a middle ground, that is a middle ground between knowing the particular arrangement on the one hand, and on the other hand, just knowing that there is an arrangement, we have in between those extremes some useful properties, namely evenness and oddness, that helped us identify a strategy for helping these poor prisoners not be executed. Now, this is illustrative of these sorts of logical distinctions between that I'd adverted to in discussion between universal, particular, and existential. When we're thinking of universal, we sometimes want to acquire more general knowledge about a group of things. For instance, all red things are colored. And this is because being red is just a specific way to be colored. Science investigates generalizations of a similar sort, like all light wave particles have a maximum velocity, for instance. Now, we don't always want that general information. Less exhaustive than such are existential claims or claims about something, but nothing in particular. For example, I'm confident someone listening at home is not wearing pants. I wouldn't be confident to say it's any specific person, but I'm pretty sure it's one of you. I put another way, think about this in the sense of if you purchased one lottery ticket out of that many from a lottery that was guaranteed to have at least one winner, you could be confident that someone would win this lottery, but you can also be confident that you won't, right? So not great odds. Here are the logical links graphically. So if you have a claim such that everything is P, then that entails that something is. Now, if you have everything is P, then you have a particular thing is. So you can plug in for P here whatever you like. Everything is pretty. If you know everything is pretty, then something is pretty. If you know everything is pretty, then pick out something in your domain, and that particular thing better be pretty. Otherwise, it wouldn't have been the case that everything was. On the other hand, you can also note that there is an entailment between a particular thing being P and something being P. If John is pretty, wink, then something is, namely me. On the other hand, here we have all that said, some putative relationships don't hold. Namely, there is no entailment relation between something being pretty and everything being pretty, right? Just because something has a property doesn't mean everything does. Similarly, you cannot infer from something being pretty to a particular thing being pretty, right? And this was, of course, the same sort of reasoning going on when we think about the lottery. Someone's going to win, but I'm not sure who. This is all sort of preliminary, though, for a very useful heuristic I'd like to introduce you to that will save you a lot of time when you're thinking about logical relationships. It's the square of opposition. It's as old as Aristotle. In fact, Aristotle developed the logic that underwrote it, and it's surprisingly useful today, as we'll see. This, in a nutshell, or in a screenshot, is the square of opposition. We're going to walk through these corners. I'm going to give you some exercises, and we're going to work on this in class, so don't worry. This is a lot of information, but it's pictures worth 1,000 words and whatnot. So we'll start here. Every S is P. What does this mean? We're going to visualize. Use one of your strategies. Here's a way to paraphrase that. Every S is P. You could say for every X, you think about X as just like anything, right? Like it's a variable, just like you'd see in algebra. If X is S, then X is P. This is just to say if X has some property, namely S, then X also has another property, namely P. We'll break this down in parts, though. Here's all of the things for every X. Like I said a minute ago, the X ranges over everything, unrestricted, all the things. Now, we want to focus on if here, because that's the next part of our expression. Now, this just restricts the domain to S, okay? So if, it's just saying if X is S, that's what we're focused on. So we start with all the stuff, and we're saying, all right, now focus on this stuff, though. Here are the S things. That's going to be our target. Okay, now on that condition, is where the then comes in, we want to focus on the P things. Here are the P things, all right? They're a subset of all the things. And what we're saying here with this expression altogether then is for everything, if it's S, then it's a P, right? And this is just to say that if you pick out any of the S things, that S thing is also going to be in the set of P things. Check. Moving on to the other corners, we have first no S is P. This is just to say that there is no overlap between these two things, which you will be able to determine if you visualize. Also, some S is P. This is just to say that something in that, or something in S, overlaps with something in P. Again, visualize. And then some S is not P. So there's something in the set of all S's that you can identify as not being a P, or not being in the set of P things. Again, visualizing. Now, I would like for you, if we were in class, I'd have you separate into groups to do this. If you have any friends, you can still do that. But really the upshot here is I'd like you to actually do that visualization that I suggested a minute ago to illustrate the other three sides of the square. Remember, they don't all need to overlap. You may need more than one diagram for a given corner, and that is the hint I will give you. We will discuss this, of course, in more detail in class. Assuming you have done that exercise, I will move on to other aspects of the square that are worth unpacking. I'm sure you saw these terms, right? Like, what do all these terms mean? There are arrows and relationships and these weird names. Subalterns. We'll talk about this. Okay. This is what a subaltern is. Basically, it's an entailment. If every S is P is true, then some S is P is true, right? That's what we were talking about a minute ago with this relationship between universal and existential. And that's encoded in the square, right? And we call that relationship a subaltern. Similarly, if no S is P is true, then some S is not P is true. Again, that's an entailment, just like the first one, right? That's what we call it, a subaltern. The first thing, if that's true, then the second thing is as well. Note, though, neither of these relationships hold in the opposite direction. So just because some S is P is true, it doesn't mean every S is P is true. Similarly, just because some S is not P is true, does not mean that no S is P is true. Here's the more rigorous definition of a subaltern. An expression A is a subaltern of expression B, just in case. If A is true, then B is true, and if B is false, then A is false. This second clause is important. By that I mean the clause that says if B is false, then A is false. If some S is P is false, that does mean that every S is P is false. And that is the sort of relationship you should expect among subalterns. Now, let's look at these contradictories. If every S is P is true, then some S is not P is false. And if some S is not P is true, then every S is P is false. Now, this relationship that we're asserting here, this contradictory relationship, works just like that. If it holds such that if one expression is true, then its contradictory has to be false. So they toggle, they flip on and off, right? Moving over here to the contraries. Contraries are such that if one is true, then another is false, but it's not exactly the same relationship that holds between contradictories. So for instance, if every S is P is true, then as a matter of fact, no S is P is false, right? But think about what happens if every S is P is false. Does that mean anything for no S is P? Well, not really. They could both be false together, right? Or no S is P could be true, right? And this is the relationship between contraries. A is a contrary to B just in case A and B may be false together, but they can't be true together. If one's true, then the other is false. Now, you could probably fill in the blanks for what a subcontrary is then. If some S is P is false, then some S is not P has to be true. But just because some S is P is true doesn't mean anything has to be the case for some S is not P. Similar to contraries, A is a subcontrary to B just in case A and B may both be true, but they can't both be false together. A few other things not in the square, but useful for thinking about it. This term converse, you may have heard this in natural language. It works like this. Every S is a P. All right, that's a statement. You want to think about the converse of it. Every P is S. See, we just flipping the S's and the P's. And this is basically how converse works in natural language. I'm going to go to the store and pick up milk, or conversely, what you mean is something like, I'm going to pick up milk and go to the store. In addition, we have contraposition. This is going to be a useful term for us. The contrapositive of every S is P is every not P is not S. What you do is you flip the P and the S and you put a not in front of it. That is contraposition. Really getting a hang of this is going to involve traversing the square. So I'm going to talk through that a little bit in anticipation of our discussion when we meet. Here's a sort of question that will tax your mind and get you familiar with the topic. So what is the converse of the contrary, or contradictory, the subaltern of the contrary, the contrapositive of every S is P? Whew, let's see. Start with this. I'm going to walk you through this. How do you solve this? Start with every S is P. All right, there we go. Now, work backwards. What's the contrapositive of that? Well, remember what the contrapositive was. We flip the S and the P and we put not in. Cool. Every not P is not S. All right. Moving on. Got to go to the contrary. Remember what the contrary was? I'll let you fill that in. And if that wasn't obvious to you, look at your square and think about it. This is the contrary of what we just had. So no, not P is not S. Okay. Now keep going. Subaltern. What's the subaltern of this? Some, not P, is not S. I'm going to do something here, namely eliminate negations, so we can make this a little cleaner. So that some not P is S, rather than some not P is not S. They are equivalent. And we're going to continue working backwards. So we see the contradictory of that, which is every not P is S. And one more, what's the converse of that? Every S is not P. So what is the converse of the contradictory, the subaltern of the contrary, the contrapositive of every S is P? It's every S is not P. Now, I'll let you do this one. What is the subaltern of the contradiction of the contrary, the converse of the contradiction of the contraposition of no S is P? Good luck. See you soon.